Have you ever stopped and wondered how an airline can price millions of different seats? Or how a delivery service can figure out thousands of routes and do it all in like the blink of an eye? Well, I'm here to tell you it's not magic. It's actually a hidden system, this incredibly powerful science for making better decisions that is running just beneath the surface of our entire world. And today, we are going to uncover its billion-dollar secret. So to really get this secret, we have to start with a question. A billion-dollar question, to be exact. Look at that number, $1 billion. That's the extra money American Airlines makes every single year. And they don't do it by adding more planes or flying more routes. No, they do it just by making smarter decisions. And those decisions are guided by the very science we're about to dig into. It's an absolutely mind-blowing number. So how on earth do they do it? How do they juggle a bazillion different variables to find that one perfect price for every single seat on every single flight? And it's not just airlines. Think about when you go on Skyscanner and it sifts through millions of options to find you the cheapest flight in seconds. It feels like magic, right? Well, let's pull back the curtain. The answer, the method behind all this magic, is a discipline called management science. And trust me, once you see it, you are going to start noticing it absolutely everywhere. So what is this thing? Well, put simply, management science, and you'll sometimes hear it called operations research. It's all about using a structured mathematical approach to make decisions. It's pretty much the exact opposite of guesswork or just going with your gut feeling. It's about finding the provably best answer to a problem. And you know what's really cool? This isn't some new tech fad that just popped up. This field actually has its roots way back in World War II. Back then, military strategists called it operations research, and they used it to optimize everything from supply lines to bombing runs. So after the war, these, battle-tested tools moved into the business world, and today they're a cornerstone of modern management. Okay, so we know what it is, but how does it actually work? Well, the secret to the whole thing lies in its most fundamental tool, the model. This quote from Da Vinci, it just hits the nail on the head. See, the goal here isn't to make things more complex. It's the opposite. It's to take a messy, complicated, real-world problem and boil it down to its most essential parts, creating a simpler version that we can actually understand and solve. So a model is really just a representation of reality. You can think of a flight simulator for a pilot, or maybe architectural blueprints for a new building. They let you test out all your ideas and make critical decisions safely without, risking a real plane or millions of dollars in construction costs. Okay, here's maybe the best analogy of all. A selfie is a model. Seriously, it's a simplified 2D representation of you. You can edit it, you can add filters, you can share it, all things you can't really do to your actual face, right? In the very same way, a mathematical model is just a simple, easy-to-play-with version of a super complex business problem. All right, theory's great, but let's make this real. We're actually going to build a simple model from scratch for a real-world problem. This way, you can see exactly how a business story gets translated into the language of optimization. It's easier than you think. So there's a really clear 4-step recipe to build our model. First, we'll define our variables, the unknowns. Second, we'll state our goal. Third, we'll list our limitations, our rules. And finally, we'll add a little common sense rule at the end. Okay, let's jump into step 1. First up, the decision variables. These are just the things the company really wants to know. In our case, Fan Milk has to decide how many sachets of its 2 products, Fan Yogo and Fan Choco, they should produce. So we'll just call these unknown quantities X1 and X2. Simple enough? Second, what's the objective? What is the end game here? It's pretty straightforward. They want to maximize their total profit. And we know they make a profit of 40 on each Fan Yogo and 50 on each Fan Choco. So how do we turn that simple goal into a little bit of math? We write it just like this. Don't let the letters scare you. The total profit, we'll just call it Z for now, is equal to 40 times the number of Fan Yogos we make, which is X1, plus 50 times the number of Fan Chocos we make, X2. And that's it. This simple line of algebra represents their entire goal. Now, for step 3, we have the constraints. I mean, a business can't just produce an infinite amount of stuff, right? They have limits: resources, time, materials. The logic here is super simple. What you use on the left-hand side cannot be more than what is available to you on the right-hand side. You can't use more than you have. So for Fan Milk, their big limits are labor and milk. And this table shows us the rules of the game.
They've got 40 hours of labor and 120 gallons of milk in total. That's what's available. The table also shows us how much of each of those resources it takes to make just one sachet of each product.
And here is how we write that down as math. The total labor used, which is 1 hour for every fan yogo and 2 for every fan choco, can't be more than 40 hours. And the total milk used can't be more than 120 gallons. These two lines are basically the rules of the game that we have to play by. Okay, we have all the pieces of the puzzle. We have the variables, we have the main goal, and we have the rules. Now let's put it all together and see what our complete business story looks like when it's told in the language of optimization. And there it is, the complete model. This whole technique, by the way, is called linear programming. We've successfully translated our business story into a language that a computer can perfectly understand. We've told it the goal, go make as much profit as possible. And we've told it the rules it has to follow. Oh, and that last line just means you can't produce negative amounts of stuff, which is just common sense. Now, a computer can take this and find the single best answer. So how does this little fan milk problem connect all the way back to our billion-dollar question about the airline? Well, take a look at this. The logic we just used for the simple fan milk problem is the exact same logic an airline uses for its absolute nightmare of a scheduling problem. The only difference is scale. Instead of 2 variables, they have thousands. Every plane, every route, every pilot, and instead of 2 rules, they have thousands of constraints. The thinking is identical, it's just the complexity is on a totally different level. So, we've just seen how to take a messy, real-world story and turn it into a clean, solvable model. You now actually understand the basic language of optimization. So think about it for a second. What complex problem in your world, whether it's big or small, what would you solve first?